numbers. So we start with letters. So we have 26 for the first one. And if they can't be repeated, it's 25 followed by 24. And then 10. Is it 9?
Yes.
It's 10 again because the numbers can be repeated. Yes?
Just kidding, Ms. Garcia.
Oh, I got this, guys.
You want to write it?
Give me this one.
15 million. Just multiply it.
You multiply.
Wait. Is it 15? Because I got 11. Because my calculator's weird. Oh, that's so this one is the next one. Because the numbers can repeat. Ooh. So you can write the next one. Okay. All right.
Huh?
Do you
Oh,
got
yeah.
the
See, look, I did this, and then I just, after that, I just go times 1,000. 15, 6, and then 5 zeros.
Thank you. So it was less because we restricted the letters. So now we're going to do it again. This time, the letters can repeat, but the numbers cannot. In my dreams. All right. So we had 26 for the first one, right? What do I write for the second? 26. 26.
10, 9, 8.
And then 10, 9, 8.
I think. Should be.
That sounds right. Or seems right. All right. Yeah.
His letters can be digits, right?
Oh,
They want more math teachers, but they don't pay us differently. So like we get paid by years of teaching. So the teachers that have been teaching 10 years make way more money than I do, but the teachers that have been teaching 20 years make way more than the people that have been teaching 10.
How long have you been teaching for?
I'm at year
6.
what?
I know.
Dang. You can do the last one. So the one that you just did was the last one.
he's already at it.
0%.
How many years have you been teaching, Ms. Garcia?
This is year
3.
technically on the pay scale is 2.
Wait, was last year your first year? It was? Oh, snap.
Last year
For
was
real? Great.
So I am one of those 20s that's up there. So I'm one of those.
25, 24, 26.
Oh no. I will be 25 next month.
I guess it.
You're the same age as Ms. Garcia.
When's your birthday, Ms. Garcia?
But you look 18. Yeah.
Eric said that. Extra credit right there.
All right. So, yeah. Okay, so the last one, nothing can be repeated. So it's 26 times 25 times 24 times 10 times 9 times 8. And if you notice, that's the smallest number up there because it has the most restrictions on it.
I like that.
All right, let's go on to all right. So the next one, we're talking about baby names, okay? So
Like jumbling letters together.
yeah. Okay.
And, that's right.
Smaller. Okay, so the name either starts with S or R, and for part A, the letters can be repeated. So how many letter choices do you have for the first spot? But it's 2, because it's S, R, R. It's only 2. If the letters can be repeated, and I know what you're thinking, well, if they choose S, they can't choose S again. You don't have to think about how the name is pronounced. I'm saying that the letters can repeat. So how many letters for the second choice?
Popular baby names. So Eric. That's 5 letters.
26. Then how many for the next one? 26. 26 and 26.
Oh, 5.
So it's basically what's 26 to the 4th power times 2. A big number.
3, 9, 5, 2.
9, 1, 3, 9, 5, 2.
Literally, you guys are extra credit.
10 points a worksheet. All right. So now part B. So same thing. The baby's name either starts with S or R. So how many different ways for the first slot? 2. Now, let's just say they chose the letter S. S can no longer be repeated. So then how many letters do we have to choose for? 20. 25. Because if you choose the letter S, you can still choose R, right?
Yeah.
So then what's the next one after 25? Then, and
607, 200. I think I did this right. 2 times 25 times 24 times 22. I already got it.
so is that smaller or bigger than the first one? Smaller because we can't repeat. So you don't have to think about logic like, oh, that's not a name. I didn't ask you what the name was. I just said how many different letters could you choose from? Yes.
Is it ever possible things that are not repeated to be bigger than those that are repeated?
I didn't see any more examples.
Oh, no, you're good. All right. Steven's still writing, though. No, you don't have to give me a present. I'm fine.
No, we don't want to. Like, we don't want to. If it's extra credit, I'll get you a gift.
That's mean. though. That's not the kindness of your heart. That's just I want something, so I'm gonna give you something.
Let's go see it. Don't give him anything.
All right. So in math, an exclamation point means something. Okay. So it's called a factorial, guys. You were doing so good, and then now not so much. Okay, bless you. So it's a way of counting the number of possible ways that a non-repeating event with n items can occur. So it is calculated by the following formula. So n exclamation is read n factorial. That means you take the number n and you multiply it by the number that comes before n. That's what n minus 1 means. That's the number before n. N minus 2 is the number before n minus 1. The number after n minus 2 is n minus 3. So you're multiplying all the numbers that come before n. And I will show you what I mean when we get to the examples that are next.
Oh my God.
Okay, if you have your scientific calculator or your graphic calculator, in a moment I'm going to tell you that the first people that could tell me how to do this on a calculator will get the participation points for today. But there's different calculators, so you only get points for what you did. So there's a button on your phone. The first person to show me the button on their phone. There's a scientific calculator. The first person to show me the button on their scientific calculator. And if you have a different brand, different brands have different buttons. So I would still give you points. And if you have a graphing calculator, the button is completely different. So give me a second. Wait. All right, go for it, Richard. Yes.
Participation points?